Have you ever wondered what lies beyond our planet? From the first stargazers to interstellar probes, discover the real stories of cosmic exploration. Close your eyes and let the universe reveal its secrets, one incredible fact at a time. Part 1. The First Stargazers. Long before rockets pierced the sky and telescopes unveiled distant galaxies, humanity's first connection with the cosmos began in silence. Imagine standing thousands of years ago on an open plain, with no electricity, no city lights, only the vast velvet of night above. The stars stretched endlessly, so many that the Milky Way itself looked like a river of silver dust. For our ancestors, the sky was not just a backdrop. It was a map, a calendar, and a mystery that called to them. The earliest stargazers were ordinary people, hunters, farmers, wanderers, who noticed that the sun and moon followed patterns. They saw how constellations rose and fell with the seasons, guiding when to plant crops or when to prepare for winter. These observations were so crucial that entire civilizations were built around the rhythms of the sky. In Mesopotamia, some of the first records of astronomy were carved into clay tablets over 4,000 years ago. Priests tracked the paths of planets, believing they carried messages from the gods. In Egypt, the rising of Sirius, just before dawn each year, signaled the flooding of the Nile, an event that meant survival for their people. Meanwhile, in Stonehenge, enormous stones were carefully aligned with the solstices, transforming the sky itself into a kind of celestial clock. But it wasn't just practical. The night sky awakened something deeper: stories. Across cultures, humans drew pictures in the stars. A hunter, a lion, a great bear. In Greece, constellations became myths, eternal reminders of heroes and gods. In China, star maps were drawn with careful precision, the oldest surviving ones dating back more than 2,000 years. Far across the ocean, the Polynesians learned to read the sky as if it were a language, navigating thousands of miles of ocean using only the stars as their compass. What is most striking is that no matter where humans lived, deserts, jungles, islands, or icy tundras, all looked up and wondered the same things. Where do we come from? Why are we here? What lies beyond those stars? In that way, the cosmos became humanity's first shared mystery, a silent bond that connected all of us under one infinite sky. When you gaze upward tonight, you see the same stars that guided ancient travelers, inspired mythmakers, and gave hope to civilizations long gone. Their questions echo in us still. Before rockets, before science, before we even had words for galaxies or planets, we were already dreamers of the night. Part 2. Galileo and the Telescope. For centuries ago, the sky changed forever. For thousands of years, humans had watched the heavens with nothing but their eyes, guided by memory and imagination. But in 1609, an Italian scientist named Galileo Galilei turned a new invention toward the night sky, the telescope. With a simple tube of glass and lenses, the universe revealed itself in ways no one had ever seen before. At first, Galileo did what no one else had dared. He aimed his telescope at the moon. To the naked eye, it looked like a glowing, smooth sphere. But through his lenses, he saw something astonishing: mountains, valleys, and craters. The moon, long thought to be a perfect heavenly body, was a world with scars and shadows, a place not so different from Earth. He turned next to the stars. What had always appeared as single points of light now became clusters, revealing that the Milky Way was not a misty band, but countless stars too faint for the eye to see. Each one, Galileo realized, was its own sun, part of an unimaginable vastness. But perhaps his most groundbreaking discovery came when he pointed the telescope toward Jupiter. To his surprise, he noticed tiny dots of light near the planet. Night after night, he watched as they moved. These were not stars, but moons for small worlds orbiting Jupiter. Today we call them the Galilean moons, Io, Europa, Ganymede, and Callisto. Their existence shattered the old belief that everything in the heavens revolved around Earth. If Jupiter could have its own moons, then Earth was not the center of all creation. His observations sparked controversy. The church and scholars of the time clung to the old geocentric model, with Earth at the center of the universe. But Galileo's telescope told another story, one that matched the theories of Copernicus, who had dared to suggest that the Earth itself moved around the sun. For his courage, Galileo was condemned and silenced, spending his later years under house arrest. Yet even as his freedom was taken, his vision of the cosmos endured. He once wrote, "E per si move," and yet it moves. The Earth, the planets, the stars, they all danced in a grand celestial order, regardless of whether humanity accepted it or not. Galileo's telescope was simple compared to today's instruments, but it marked the beginning of modern astronomy. For the first time, we saw the heavens not as unreachable perfection, but as real places, worlds waiting to be explored. And with each lens pointed skyward, we stepped a little closer to understanding our place in the universe. When you look at the moon tonight, remember that moment when one man peered through a modest telescope and found that the universe was far more alive, complex, and beautiful than anyone had dared to imagine. Part 3. The Age of Rockets. For most of history, the stars felt unreachable, distant lights in an infinite night. But in the 20th century, something extraordinary happened. Humanity found a way to break free from Earth's gravity. The dream of touching the sky was no longer a story told by poets or mythmakers. It became science, engineering, and courage. It began with fire and thunder. In 1957, the Soviet Union launched Sputnik 1, the very first artificial satellite. It was small, only the size of a beach ball, but its beeping signal from orbit was louder than any shout from Earth. For the first time, humans had placed something in space. The night sky would never be the same. Soon after, rockets carried not just machines, but living beings. A small dog named Laika became the first creature to orbit Earth. Her journey was short and tragic, but her sacrifice marked the beginning of spaceflight. Then came Yuri Gagarin, a young Soviet pilot with a warm smile, who in 1961 became the first human to leave Earth. As he circled the planet in Vostok 1, he looked out the window and famously said, "I see Earth. It is so beautiful." On the other side of the world, the United States answered with its own missions. Engineers, scientists, and astronauts worked with relentless determination. Their program, Apollo, aimed higher than anyone had ever dreamed, not just orbiting Earth, but landing on the moon itself. In 1969, Neil Armstrong stepped onto lunar soil and spoke words that carried across the planet. That's one small step for man, one giant leap for mankind. The rockets of that era were immense, like towers of fire and steel. Each launch shook the ground, carrying hopes, fears, and dreams skyward. Behind them were countless stories. Scientists like Sergei Korolev, who designed the early Soviet rockets in secrecy, and Wernher von Braun, whose vision of space travel helped shape America's missions. They were engineers and dreamers, bound by a single idea, that humanity could reach beyond Earth. But this new age was not only about competition. Slowly, Space became a place of cooperation. The International Space Station, orbiting silently above us, was built by many nations working together. Today, astronauts from across the world share meals, laughter, and experiments in microgravity, proving that space is a frontier for all of humanity. The age of rockets showed us something essential. The sky is not a limit, but a beginning. Every launch, every orbit, every footprint on the moon is a reminder of what humans can achieve when curiosity is stronger than fear. If you listen closely, perhaps you can still imagine it. The echo of a countdown, the roar of engines, the trembling ground, and then silence as the rocket pierces the blue and enters the black. From that moment on, the universe was no longer untouchable. We had taken our first steps into the stars. Part 4, Voyager and the Golden Record. In 1977, two small spacecraft left Earth on a journey unlike any before. Their names were Voyager 1 and Voyager 2. At first, their mission was simple: to study the outer planets of our solar system. But hidden in their design was something far greater, a message in a bottle, cast into the ocean of the stars. The Voyagers were built to last only a few years, long enough to pass Jupiter, Saturn, Uranus, and Neptune. Yet even now, more than 4 decades later, they continue their flight, further from Earth than any human-made object has ever traveled. They are silent travelers, powered by the slow decay of plutonium, whispering faint signals across billions of kilometers. What makes them remarkable is not only their journey, but what they carry. Each spacecraft holds a golden phonograph record, a time capsule meant for anyone, or anything, that might one day find them. The golden record contains greetings in 55 human languages, the sounds of rain, waves, wind, birds, and laughter. It carries music from across cultures: Bach and Beethoven, Navajo chants, Senegalese percussion, and Chuck Berry's Johnny B. Good. And it carries 116 images, from DNA and human anatomy, to a mother nursing her child, to landscapes of Earth's forests, deserts, and cities. The record was created by a team led by the astronomer Carl Sagan. He and his colleagues knew that the chances of it ever being found were almost zero. Yet they believed it was worth sending, a message of who we are, and what we dream to be, carried into the eternal night. Sagan described it beautifully. The spacecraft will be encountered and the record played only if there are advanced spacefaring civilizations in interstellar space. But the launching of this bottle into the cosmic ocean says something very hopeful about life on this planet. In August 2012, Voyager 1 crossed a boundary no spacecraft had ever reached: interstellar space. Beyond the influence of the sun's solar wind, it entered the realm between the stars. Its signal is faint. It takes over 20 hours for a message to travel from Earth to the spacecraft, moving at the speed of light. And yet, it still speaks to us. Someday, the Voyagers will go silent. Their power will fade, their instruments will shut down, and they will drift forever, carrying humanity's golden gift. In a billion years, long after Earth itself has changed beyond recognition, those records will still be gliding among the stars, waiting, patient, timeless. Perhaps no one will ever find them, or perhaps, in some faraway age, another intelligence will discover them, place a needle on the golden grooves, and hear our voices. They will hear the sound of rain on Earth, the music of our hearts, the laughter of children, and for a moment, across an impossible distance, they will know that once, long ago, on a small blue world circling an ordinary star, we were here. Part 5. Hubble and the Deep Field. When the Hubble Space Telescope was launched in 1990, expectations were sky high. For the first time, humanity had placed a powerful observatory above the blur of Earth's atmosphere, with a mirror designed to capture the faintest light in the cosmos. But soon after deployment, something went wrong. Hubble's vision was blurry. A flaw in its mirror meant that the stars appeared smeared, the galaxies out of focus. It was a devastating discovery, one of the most embarrassing mistakes in space history. But NASA refused to give up. In 1993, astronauts aboard the Space Shuttle Endeavour carried out a daring repair mission. They installed corrective optics, almost like giving Hubble a pair of glasses. From that moment, Hubble began to see with clarity beyond anything humanity had known before. Among its greatest contributions came in 1995, with an experiment that seemed almost foolish at the time. Astronomers decided to point Hubble's camera at a tiny, empty patch of sky near the constellation Ursa Major. It was so small that it looked completely dark, like nothing was there. For 10 days, Hubble stared into the darkness, collecting every photon it could. When the image was revealed, the world gasped. Instead of emptiness, the picture showed thousands of galaxies, spirals, ellipticals, clusters, each one containing billions of stars. Later versions of this image, called the Hubble Deep Field and Ultra Deep Field, went even deeper. In a patch of sky no bigger than a grain of sand held at arm's length, Hubble revealed over 10,000 galaxies. The implication was breathtaking. If such a tiny sliver of sky held so many galaxies, then the entire universe must contain hundreds of billions, perhaps more. Suddenly, the cosmos felt both unimaginably vast and profoundly rich. Hubble also became a storyteller of beauty. It captured the pillars of creation, towering clouds of gas and dust where new stars are born. It revealed the expansion of the universe and measured its age more precisely than ever before. Its images weren't just science, they were art, windows into eternity. For more than 3 decades, Hubble has orbited Earth, circling every 90 minutes, sending back treasures of light. Even as new telescopes like James Webb rise to continue the story, Hubble remains one of humanity's most beloved instruments. What makes the deep field images so moving is not only their scientific value, but their quiet reminder. In what seemed like nothing, a patch of black sky, there was everything, galaxies beyond count, each with stars, planets, and possibilities we can barely imagine. It teaches us that emptiness may not be empty at all. Sometimes, if you look closely enough, the universe reveals wonders hidden in the dark. Part 6. The Search for Exoplanets. For centuries, humans wondered, are there other worlds like ours? We looked up at the stars and imagined planets circling them, but there was no proof. The first confirmed discovery came only in 1992, when astronomers Alexander Woolsey and Dale Frail detected planets orbiting a pulsar, a dead, rapidly spinning star. These were strange, hostile worlds, but they proved the point. Planets exist beyond our sun. Then, in 1995, Michel Mayor and Didier Queloz announced a discovery that shook astronomy. Using a telescope in southern France, they found a planet orbiting a sun-like star, 51 Pegasi. It was the first true exoplanet around a normal star. But it wasn't Earth-like at all. It was a giant world, bigger than Jupiter, orbiting so close to its star that a year lasted only 4 Earth days. Astronomers called it a hot Jupiter. This was unexpected. It challenged everything we thought we knew about planetary systems. After that, the floodgates opened. New techniques, especially the transit method, allowed astronomers to detect planets when they passed in front of their stars, dimming the starlight ever so slightly. Then came NASA's Kepler Space Telescope in 2009. For nearly a decade, Kepler stared at a single patch of sky, watching over 150,000 stars, searching for tiny dips in brightness. The result was extraordinary. Thousands of exoplanets of all kinds and sizes, from scorched lava worlds to gas giants floating far from their suns. Perhaps the most thrilling discoveries were the Earth-sized planets in the habitable zones of their stars, regions where liquid water could exist. Among the most famous is the TRAPPIST-1 system, with 7 rocky planets orbiting a cool red dwarf star only 40 light-years away. 3 of them lie in the habitable zone. If water exists there, they might resemble Earth in ways we can only imagine. The James Webb Space Telescope, launched in 2021, is now taking this search further. With its powerful instruments, Webb can study the atmospheres of exoplanets, looking for gases like oxygen, methane, or carbon dioxide, potential signs of life. Already, Webb has detected carbon dioxide on some distant worlds and hints of chemical complexity. Today, astronomers estimate that almost every star in the Milky Way has at least one planet. That means there could be hundreds of billions of planets in our galaxy alone, and trillions across the universe. Among them, surely, are worlds with oceans, mountains, clouds, and maybe even life. We have not yet found a second Earth, but the search has only just begun. Each exoplanet discovered is another reminder that our solar system is not unique, that the story of planets is universal. Somewhere out there, under an alien sun, a world may be waiting, familiar, yet entirely new. Part 7. Black holes and gravitational waves. Black holes were once just a strange consequence of Einstein's theory of general relativity. In 1916, Carl Schwarzschild calculated that if enough mass were squeezed into a small enough space, gravity would become so strong that nothing, not even light, could escape. For decades, they were considered mathematical curiosities, not real objects. But gradually, evidence grew. Astronomers observed stars orbiting invisible companions, moving so fast that only a black hole's gravity could explain it. At the center of our own galaxy, the Milky Way, scientists tracked stars whipping around an unseen giant. This hidden monster, called Sagittarius A*, is a supermassive black hole with 4 million times the mass of our Sun. Still, black holes remained mysterious. Then, in 2015, something extraordinary happened. Deep underground in the United States, the twin detectors of the Laser Interferometer Gravitational Wave Observatory, LIGO, recorded a faint ripple in space-time itself. It was the sound of 2 black holes colliding over 1 billion light-years away. For the first time, humanity had detected gravitational waves, tiny distortions in the fabric of the universe, exactly as Einstein had predicted a century earlier. The signal lasted less than a second, but it carried immense meaning. It proved that black holes not only exist, but they can merge, sending out cosmic vibrations across the universe. Since then, LIGO and its European partner Virgo have detected dozens of these collisions, revealing a hidden symphony of the cosmos. Each ripple tells the story of massive objects spiraling together, releasing more energy in a moment than all the stars in the universe emit combined. In 2019, another breakthrough came. The Event Horizon Telescope released the first image of a black hole shadow, a glowing ring of light around a dark abyss in the galaxy M87. It was a photograph of the unseeable, humanity's first glimpse of the edge of a black hole. In 2022, the telescope turned its gaze toward the Milky Way's own center and captured the shadow of Sagittarius A*, proving beyond doubt that black holes are real. Black holes remain the most extreme objects in nature. At their heart lies a singularity, where the known laws of physics break down. Around them, time itself bends. To an outside observer, anything falling toward the event horizon seems to slow, freezing in place, even as it plunges inward. They are not just destroyers, though. Black holes shape galaxies, influence star formation, and may even play a role in the birth of new cosmic structures. Some scientists even speculate that in their depths might lie clues to a deeper theory of physics, one that unites gravity with quantum mechanics. Gravitational waves and black hole images remind us that the universe is alive with phenomena we are only beginning to sense. Once, black holes were only in the realm of theory. Now, we can listen to their collisions and see their shadows. They are no longer just equations. They are part of our cosmic story. Part 8. The International Space Station. Life in orbit. Since November 2000, humans have maintained a continuous presence in space aboard the International Space Station, ISS. Orbiting roughly 408 kilometers above Earth, the ISS circles the planet every 90 minutes, witnessing 16 sunrises and sunsets each day. It is the largest human-made structure in orbit, a testament to engineering, cooperation, and human curiosity. The ISS is not just a laboratory, it is a home. Astronauts float in microgravity, moving effortlessly from one module to another, using Velcro, handrails, and footholds to anchor themselves. Every action, from eating to sleeping, requires adaptation. Water doesn't pour from a cup, it forms floating spheres. Fire behaves differently. Even simple gestures, like brushing teeth, become a practice in precision and patience. Life on the ISS is a balance of work, science, and maintenance. Astronauts conduct experiments that can only be done in microgravity, studying protein crystals, observing fluid dynamics, and growing plants without soil. These studies inform not only space exploration but also medicine, materials science, and understanding of fundamental physics. The station itself is a marvel of international collaboration. Built piece by piece, it combines modules from the United States, Russia, Europe, Japan, and Canada. Astronauts from multiple countries live together, sharing meals, experiments, and the small challenges of confined life. It is a floating city, demonstrating that humans can work together even under extreme conditions. Despite the wonders, life in orbit is not without hardships. Sleep is fragmented, bones and muscles weaken. Radiation is a constant concern. Communication with family and Earth helps, but the distance reminds astronauts daily that they are part of a thin, fragile line connecting humanity to the stars. Yet they endure, adapt, and thrive, sharing the experience with millions watching from below. From their vantage point, astronauts see Earth as a delicate blue sphere, devoid of borders. It is a perspective that inspires awe and humility, reminding humanity of the planet's fragility and the unity of life upon it. Many have said that this view changes them forever, a quiet, personal revelation that the whole world is interconnected. The ISS has been home to astronauts from dozens of countries, hosting over 240 individuals since its first resident cruise. Each mission leaves a legacy of research, international trust, and proof that humans can live and work together in the most challenging environments. Above us, orbiting silently and endlessly, the ISS is more than a space station. It is a bridge between nations, between science and imagination, and between Earth and the endless universe beyond. Part 9. Dreaming of Mars, our next home. Mars has fascinated humans for centuries. Its red hue, visible even to the naked eye, has inspired myths, telescopic studies, and dreams of other worlds. Today, Mars is no longer just a point of light in the sky. It is a destination, a challenge, and perhaps a future home for humanity. The first close-up images came from the Mariner 4 spacecraft in 1965. It revealed a cratered, desolate landscape, far different from the canals imagined by 19th century astronomers. Yet, each new mission brought more detail. The Viking landers in the 1970s analyzed soil, searching for traces of life. Nothing definitive was found, but the search itself sparked a new era of curiosity. In the 1990s and 2000s, rovers like Sojourner, Spirit, Opportunity, and Curiosity explored the Martian surface. They discovered dry riverbeds, minerals formed in water, and evidence that Mars had once harbored a much warmer, wetter climate. These discoveries shifted our understanding. Mars had not always been the barren desert we see today. Once, it may have been capable of supporting life. The next step is sending humans. NASA's Artemis program, SpaceX's Starship, and other private and international efforts aim to make Mars reachable. Plans include multi-year missions, habitats to protect against radiation, and systems to generate water, oxygen, and food. Every detail is painstakingly studied because a mistake on Mars could be fatal. Yet, the dream endures. A human footprint on the red soil, the first colony slowly expanding across the Martian plains. Scientists also consider the profound challenges. Gravity on Mars is only about 38% of Earth's, affecting muscles and bones. Dust storms can engulf the entire planet. Temperatures swing wildly, often below -60 degrees Celsius. Communication with Earth will have delays of up to 20 minutes one way. But with each challenge, engineers and astronauts devise solutions, proving that human ingenuity can rise to meet the most extreme environments. Mars also inspires philosophical reflection. Looking at the red planet, we wonder not just if we can survive there, but what it means to expand life beyond our own world. Every rover, every satellite, and every simulation teaches us about our own planet, the fragility of ecosystems, and the importance of cooperation for survival. Dreaming of Mars reminds us that exploration is a human imperative. Even as we study its rocks, map its valleys, and prepare for habitation, Mars reflects our curiosity, resilience, and desire to reach further. It is not just a destination. It is a mirror for our ambitions and a promise that humanity's story continues beyond the blue sky of Earth. Part 10. What awaits beyond? The future of cosmic exploration. As humans stand on the threshold of interplanetary travel, the universe opens like never before. The 21st century is not just about observing the stars from afar. It is about reaching toward them, exploring planets, asteroids, and moons, and imagining what lies beyond even our wildest dreams. Missions to Mars, planned trips to the moons of Jupiter and Saturn, and telescopes like James Webb are pushing the limits of knowledge. Scientists are studying icy moons, such as Europa and Enceladus, where subsurface oceans may harbor life. Probes like New Horizons revealed the distant world of Pluto and the edge of the Kuiper Belt, showing us that even the solar system's outer reaches are rich with mysteries. Humanity also looks outward with long-term visions, building self-sustaining colonies, mining asteroids for resources, and eventually sending interstellar probes to neighboring star systems. Concepts such as Breakthrough Starshot propose tiny spacecraft traveling at a fraction of the speed of light to reach Alpha Centauri in decades rather than millennia. Though these missions exist only on paper for now, they represent the relentless drive to explore, understand, and inhabit the cosmos. The future is also philosophical. What does it mean to be a spacefaring species? As we step beyond Earth, we carry our history, our culture, and our curiosity. Every satellite, rover, and telescope expands the scope of our perspective. We are learning not only about distant worlds, but also about ourselves, our resilience, our ingenuity, and our place in the vast expanse of the universe. Dark energy and dark matter remain puzzles, invisible forces shaping the cosmos. Black holes still conceal secrets at their cores. The possibility of life elsewhere challenges our assumptions. Each discovery brings both answers and new questions, reminding us that exploration is an endless journey. For anyone looking up at the night sky, the message is clear. The universe is waiting. Beyond the planets we know, beyond the stars we can see, countless worlds and phenomena await understanding. Each generation will extend the reach of human knowledge further than the last, continuing the story that began with the first stargazers on Earth. The cosmos is vast, quiet, and full of wonder, and though we are small in comparison, our curiosity, courage, and imagination ensure that humanity's journey among the stars will continue, for as long as there is someone to look up and wonder what awaits beyond.